The classical physics rules state that a negatively charged electron and a positively charged proton would crash into each other because opposites attract. The electron orbiting the protons would not be able to orbit more than a fraction of a second without being compelled to mash together. Quantum mechanics explains why this is not always true. Quantum mechanics is the study of a particle at a subatomic level. Democritus was the first man to come up with the concept of matter being made up of stuff. He called the makeup atomos. This is the original word from which we derive the term atoms. The Greek letters spell the word atomos, and this is how Democritus would have first introduced the concept to the world. Aristotle challenged the ideas of Democritus with the theory that matter is indefinitely divisible. There were 3 laws created that affect every aspect of quantum mechanics. Law number 1 is the conservation of mass. This law states that the mass cannot be created or destroyed. This was discovered in 1789 by Antoine Lavoisier. Law number 2 is the law of definite proportions. This states that a chemical compound always contains exactly the same proportion of elements by mass. This was discovered in 1799 by Joseph Proust. Law number 3 is the law of multiple proportions. This was discovered in 1803 by John Dalton. The law states the ratio of masses will combine with 1 gram of another is always a simple whole number ratio. For example, 1 gram of hydrogen plus 8 grams of oxygen, and then 1 gram of hydrogen plus 16 grams of oxygen is 16 over 8, or 2 over 1, which is a small, simple whole number ratio. A law tells you what is happening. A theory is an idea you believe to be true, but have not yet proven. John Dalton had some ideas he believed to be true. These ideas became known as John Dalton's atomic theory. Dalton's theory had 5 major points. The first one starting with, matter is made up of atoms. Atoms are indivisible and indestructible. Atoms of different substances are somehow unique. Atoms combined in simple whole number ratios. Atoms of the same element are identical. Many of Dalton's theories have been proven laws, but a couple of them still remain as theories even to this day. John Dalton had the first idea of what an atom looked like. He believed all matter was made up solely of little circles which he thought to be atoms. And his first idea of an atom looked like this, a circle. In 1865, the law of octaves was discovered by John Newlands. The law stated if chemical elements are arranged according to increasing atomic weight, those with similar physical and chemical properties occur after each interval of 8 elements. The law of octaves is very important because it is what we use to draw the periodic table. Using the law of octaves, Dmitri Mendeleev has been credited in 1869 with creating the first periodic table. The table had 8 columns and was organized with physical and chemical properties. Mendeleev left holes in his table because he knew more elements were yet to be discovered. At the time he created the first periodic table, only 60 elements were known. The law of octaves allowed Mendeleev to predict additional elements and their chemical properties. In 1897, Thomson built a cathode ray tube with a metal cylinder on the end. This cylinder had two slits in it, leading to electrometers which could measure small electric charges. He found that by applying magnets to the tubes, it changed the way the charges bent. It proved the charges emitted from the tubes were originally negative. While performing the experiment, he found out the charge to mass, the magnitude of deflection equaled charge over mass. The charge to mass ratio was so large that the particles either carried a huge charge or was 1,000 times smaller than a hydrogen ion. Thomson came up with the idea that the cathode rays were made of particles that emanated from within the atoms themselves, which was a very bold idea. Thomson's idea for the structure of an atom was negatively charged particles swimming in a sea of positive charge. This is also called the plum pudding model. J.J. Thomson named the negatively charged particles corpuscles, which got later named the electron. Robert Milken developed the oil drop experiment. He observed the rise and fall of small drops of oil suspended between electrically charged metal plates. When he varied the charge on individual oil drops and measured their speed, he noted that they rose and fell at either the same rate or at integral multiples of that rate. This assured that all electrons were alike and carried the same charge. Milken published the first value of the electronic charge. Rutherford discovered three types of radiation. 1. Alpha, which are large positive particles. 2 was the beta, which are small negative particles. And then the third radiation, which was the gamma. A gamma particle has no mass and no charge. In 1909, Rutherford used his newly discovered alpha particles and shot them at a very thin sheet of gold foil. He found out that while most of the alpha particles passed straight through the foil, a small percentage deflected at a very large angles, and some even backscattered. Rutherford concluded that only the particles that encountered a direct collision with the gold nucleus were deflected or scattered backwards. In his model of the believed atom, the nucleus was completely positive, while the electrons floated around the positive center, which were all enclosed in a circle. In 1932, Chadwick discovered an unknown particle in the atom's nucleus. This particle became known as the neutron. Because of its lack of electronic charge, Chadwick's discovery made it possible to create elements heavier than uranium in the laboratory. Chadwick's atom was the first model published with electrons orbiting the protons and neutrons. Niels Bohr developed the next atomic model that explained flame tests, atomic emission spectrum, and helped understand the position of electrons. Niels Bohr came up with the first atomic model to have energy levels. Bohr believed the higher the energy level, the more energy electrons will have. If the electron goes from a high energy orbital to a lower energy orbital, a photon will be emitted. When a photon is absorbed, the electron goes from a low energy to a high. Thanks to these 12 men and probably a lot more, atoms, particles, and radiation were discovered. Quantum laws were made. These laws do not follow the classical physics laws, and it took a lot of hard work and determination to figure that out. Quantum mechanics brings an understanding to science that was never before held.